Good morning, good evening, good afternoon. Welcome to another session with Project Dontabhaktuni. And it is 10:06 a.m., so we are going to start our workshop. As you all know, today's workshop is on use of Python along with AI for pharmacometrics. And this workshop is going to be conducted in 3 sessions. So today is your day 1 of the session. And next week would be your session 2, followed by the 3rd session, which would be on the 16th. All right. So with that, let me tell a little bit more about myself and Project Dontabhaktuni. For those of you who don't know me, I am Aruna Dontabhaktuni, the founder of this nonprofit called Project Dontabhaktuni. So Project Dontabhaktuni is a nonprofit organization that is created to support scientists and students from around the world. And what we are committed to is to support you in growing your career by providing you workshops, trainings, and mentoring programs. How can you support us? You can support us by joining hands with us and help us by sharing what you learn here with others that you know in your career, your friend circle, etc. And our motto is to empower you so you can empower others. I briefly shared about me. I am Aruna Dontabhaktuni. I am the founder of this organization, also the founder and CEO of PharmaPro Consulting, and founder and CEO of Regkey. More about that later. So just wanted to give you an idea about today's workshop. In today's workshop, we have close to 100 participants, and we had to limit this to only 100 because we want to ensure that we are able to provide you the necessary support and guidance. And beyond 100, it would become difficult for us. So we have limited today's workshop to 100 participants, and just wanted to give an idea is to you who else is with you in this workshop. So we have majority of our participants have a PhD degree, followed by PharmD and Masters. And we have participants from 26 countries joining us, which is really amazing. And let me also share about what our previous workshops have been. We have done workshops on non-compartmental analysis using NCA, using R. We also have done other workshops, and you can learn more about them by going to our website. Also by attending or joining our YouTube channel, where we post all of these workshops and the information about them. And we have also hosted workshops on public speaking, leadership development, etc. And we, in the past, have hosted a workshop on, which was the 3-month certification program. Again, you can learn about all of this on our website and our YouTube channel. So I invite you to please join us and follow us on YouTube so you can get more information about new workshops that we would be hosting, etc. as well. And do follow us on LinkedIn. Most of our updates are provided on LinkedIn. All right. So with that, really excited to share that we have had trained over 3,500 participants from 45 countries in the past 5 years. And we want to continue to keep doing this and would love for your participation in the process as well. So one of the things that we strongly believe in, and that is one of the reasons why we continue to host these workshops, is a quote that Lincoln had, which says that give me 6 hours to chop down a tree, and I would spend the first 4 hours sharpening the axe. And as a scientist, I strongly believe in the same, especially in today's day and age where science is expanding at a very rapid pace. And for us to keep ourselves up to date with the changes that are happening, especially with the change of including AI, we have to spend a lot more time in expanding our knowledge. And that is what has been the precursor for us to create this workshop for you today, wherein we are bringing in talking about use of AI for pharmacometrics. Before I get into the details of today's workshops, just wanted to give a shout out to our sponsors. So Red Key, as I mentioned to you, is one of the new organizations that has joined us in sponsoring this workshop. So Red Key is an AI co-pilot that is used for all regulatory needs. So Red Key is a trusted regulatory intelligence platform that is powered and curated with continuous learning. It has multiple different modules built in, and it is not just AI, it is AI along with access to domain experts. It covers different aspects of regulatory needs, from document writing to competitor intelligence, personalized news stream, document insight analyzer, also global health authority form submitter. And all of this have been built on a strong AI core with a guidance chat platform. And that is what makes Redkey unique and also an award-winning platform, that it encompasses various tasks required in the regulatory prep and submission process. And another shout out to our sponsor, PharmaPro Consulting, which is a consulting company focused on pharmacokinetic, pharmacodynamic modeling, as well as clinical pharmacology and regulatory affairs. This organization is certified as a women-owned business in US and in New Jersey. So with that, let me bring us to our workshop for today. That is Python with AI for pharmacometrics. Before I hand this over to our leader leading the workshop, just wanted to give you a quick overview of Dr. Somdeep Datta. Dr. Somdeep Datta has a bachelor's from IIT Kharagpur and has a PhD from Princeton University. He spent over 13 years in Goldman Sachs in cloud computing and automation, and then worked for Beacon Platform in the cloud computing automation division. He currently is the Chief Technology Officer at Reiki, and he is an expert in the field of AI. And it's really an honor for us to have him here with us today to talk to us about how can we use Python, which is an open source tool, for various pharmacometric applications. So with that, I'm going to hand this over to Somdeep.
All right. Hello. So I'm Somdeep. Now, one of the things that I just heard, you probably heard, is that I come from an engineering background, and here I am. Most of you have PhDs or masters in pharmacometrics fields. So I will just be I will just admit humbly that probably most of you know more pharma and more pharmacometrics than I do. Uh, what I bring in here is an experience with programming. In fact, in my career, well, that's for more than 20 years, I have coded in many languages, starting with Fortran, then C, C++, Rust, Python, R, MATLAB, etc. Python is probably the easiest. And so, yeah, I think you will all find that it's it sometimes, in fact, looks like English. So without too much more, let me share my screen and get on with the material. Uh, I am not going to tell you, at least not in today's work, not in today's lecture, that why you need to do Python, Python versus R and all that. Today we will just dive straight into Python. I understand that many of you are actually first-time programmers, so we'll go through some of the basics first, and then we'll focus on the elements of Python that are more useful for scientists like you. In the later lectures, like lecture 2 and 3, we can probably cover more about the pros and cons, and we can also hear your experiences about why you are learning Python and so on. Okay, so let me start by sharing my screen.
So while Somdeep is getting his screen up, wanted to talk about a few logistics. So wanted to first is you don't need to take any notes while the workshop is ongoing because we're going to be recording this workshop and you will have access to this workshop in the next 24 hours. The second is you don't need to even have Python downloaded onto your computers because Somdeep has ensured that all this information is in Google Colab, and you can actually work directly on the Colab itself. So you don't need to have Python downloaded onto your computers. And in terms of the homework assignments, we also do know that several of you who are joining this workshop, Python is a completely new language. Some of you are completely new to even programming. So we have ensured that we provide you information in bite-sized pieces so you're able to digest and also understand. Our objective is that you actually learn uh, these concepts more than whether you're doing it right or not. So please keep that in mind. And all the participants in the workshop will also have access to a contact who would be your team leader, who's going to help you out, address any questions, and or if you require to reach out to Somdeep or a couple of our other tutors who are Python programmers, part of the RegKey programming team, they also will be available to answer questions. And believe me when I say this, we do not, we strongly encourage you to ask questions. There is no question that is a wrong question or a stupid question. All right. So with that, I'm going to hand this back to Somdeep.
So here is an agenda you can see on the screen, what we are roughly going to cover in the 3 lectures. Today we are going to cover more of the basics, but we will very quickly dive into packages like NumPy and SciPy, because we know that is what is more important to your scientific work. Next week, we will cover pandas, data frames, more plotting, and then we'll start getting ourselves into machine learning methods such as random forests. In the week 3 agenda, I have kept a little bit uh, open for now because we want to see participant feedback and we want to hear more what you want to learn before we figure out exactly what we are going to cover in week 3. Okay. All right. So next, how do you run Python? There are several ways to run Python. And in fact, let me just show you by examples. The easiest one, one of the ways is that you can actually, once you install Python in your computer terminal, you can run it right from your terminal. So for example, in my Windows machine, I have installed Python, so I can just do something like this that enables the Python interface. And now I can run Python commands, which can be simple math like this. I'm just giving you some examples. So this is a quick way to run single Python commands one by one. Of course, you can't do, it's okay for quick testing, but you can't do too much here. So that is just running Python in your terminal. Okay. Now, production processes, when you're writing, when you want to run big batches or more complex algorithms for for your analysis, you will probably use something like an IDE, and you will write down your programs in a script, which kind of looks like this. This is VS Code, and don't be scared because I'm just going to show you what it looks like, but we are not going to use it in to, in this particular course. VS Code requires a little bit more setup, but what you can see here is you write your scripts, you can manage all different scripts using a sidebar, and here you also have a terminal. Those of you who has used RStudio might realize that schematically it looks very similar to RStudio. And in fact, you can also use RStudio for Python coding. These days it supports Python too, right? So that is the second method by which you can you can use Python. You write it into scripts. The third one is notebooks, and that is actually what we are going to use in this particular course for the next 3 lectures. You will see what a notebook looks like very soon. The main advantage is that in the notebook you can have your code. You can also write text descriptions, which can also have formulas in LaTeX and all that. And moreover, when the code executes, the output of the code, the numeric results or even plots, you can see in the notebook itself. And so notebooks are extremely useful for sharing or teaching, like in courses like this. And yeah, of collaborating with other people where you want to just toss ideas. Some examples of notebook platforms are Jupyter Notebooks, Google Colab, Kaggle, and there are many more. For this course, we are going to use Colab. And before I jump into the Colab platform, what I just wanted to tell you is that at the end of this lecture, I am going to share this presentation slide also with you. And one of the things this slide will also contain is links to the Colab worksheets, where there will be all the sample code that I am going to run through in the course. You will see it there. So you don't really need to write down everything that you are seeing in the screen today. So you can just focus on understanding the concepts, and you don't really need to jot down because you will have access to the material right here. Yeah. So that being said, I'm going to jump into the code. The other note is that as I'm covering the material, I am going to take, so this is the material we are covering today, and we will have 3 breaks, or rather, let's call it 3 pauses where I will take questions. So so I will ask for it. So that would give you an opportunity to, get anything clarified.
So,
So
by the
now,
way, just wanted to cover some logistics in terms of questions. If you have any questions, please feel free to put in the chat. When Dr. Datta will take a break, he will take those questions. The other option that you would also have is to raise your hand. and I will unmute you so you'll be able to ask the question then as well. Okay. So Dr. Datta has ensured that there are pauses as he's going through the concepts. So you will have the opportunity to ask questions. However, if you have not had, you still have questions post the workshop, and as you're going through the lecture recording, you can always send us an email and we would be able to address that, or ask those questions of your team leader. If he or she is not able to address, that's when it will get forwarded to us or the tutors during the program. Okay, thank you. Back to you, Sumdip.
Okay. So let's jump to the Colab worksheet. So this is how Google Colab looks like. Uh, it is free. Uh, the best part about Google Colab is that you really don't have to install Python in your computer. So it runs in a Google server. Uh, this connects basically means that it's going to connect to a server that Google is providing for you to use for free. If you want to use more power, then maybe you need to pay for it, but we don't really need it right now. All right. So now, what is the simplest thing you can do with programming? Of course, you can use it like a calculator, as you saw. Uh, One thing to note in Colab is that it has two kinds of things. Where I'm typing right now is a coding cell. You will recognize it by this arrow right here. And if you bring your cursor somewhere here, just below the last cell, or somewhere in the middle, you will see the option to add more. You can either add another coding cell or another text cell. Text cell means here you can write your notes. Uh, this is an example. And you can, of course, do things like any kind of fancy formatting and all that, right? So this is for writing notes, and this is for writing code. When you write a code and you want to execute it, just press that. Well, this is my first time executing, so it took some time to start up the server. And now that it has started the server, you will see that it's showing you RAM, disk, etc. So that means you are connected. Now you can run codes very quickly. Okay. All right. So of course, the simplest thing you can do is do math, addition, multiplication, 2 times 3. The programming language code for power 2 to the power 3 is 2 stars in Python. So this means 2 to the power 3. And here is 2 divided by 3. All right. Now, of course, we don't want to just use it like a calculator. We want to do more. The next concept in programming is that you can store the result of your calculation into a variable. You can give it a name to the result, right? So for example, you could say that uh, result equal to 2 divided by 3, right? And then you could say, okay, print result. Similarly, you could do, let me call dose is 10. My volume is 5. Therefore, my concentration equals dose divided by volume. That is going to calculate all that. And now let's see print concentration. Now, of course, here I used single letters. Now, in addition to teaching or telling you some programming concepts, I also wanted to tell you more about best practices. One of the best practices that It might be very quick. You might think that it's very quick to, write, give your variable names very simple and short names because you can type faster. But as you write more and more code, you will see that, oh, I don't remember what D meant or what V meant. So one of my strong advices would be that whenever you're giving variable names, give it longer names, even if it means you need to type more. So don't call it D, just call it dose, you know, call it volume, and call it concentration, right? There is a little tilde mark under it. It basically is warning you that, oh, you're calculating D by V, but you have not actually defined D because, we just changed it into D. So, but we have defined dose. You may have noticed that Colab also has many helpful features. As I'm typing, it kind of auto completes. It knows what are the various things that are possible. So it just prompted, and volume is one of them here. and here, concentration. So what that means is you don't really have to worry about giving short names because of autocompletes. You can actually write code fairly quickly here, right? These are some really basic things about programming. So now we learned how to do simple math and how to store the results uh, in variables. We have actually learned one kind of data. All of these things that you see here are numbers. Actually, let's just see what kind of numbers. In order to find out what kind of uh, data or a variable you have defined, you can use the function type. So let's call it type of dose. And it tells you that this was actually an integer. See, when you just write 10. Uh, let's find out type of concentration. This was actually floating point, as in it also has a fractional part. Usually, the result of a division operation is a floating point, even if you started out with integers. You could have also told to use this as a floating point right away, because practice dosage is not just going to be integers; it could also be 10.5, 10.3. If you have 10.5, of course, it will also be floating point. Uh, Even if dose is 10, but you still want to call it a floating point, you could just have a dot. Okay. So far, we have seen two kinds of data types, integers and floating points. Let's just jump into the next one. And I'm actually going relatively fast here. If you have any, because I think these are very basic concepts, but if you have questions, just uh, type it down in the meeting chat. All right. So we learned about integers and floating points. The next one to get familiar with are character strings. So for example, I could say my name equals is Somdeep. So if you want to define a string of characters, you usually do that with these quotes. In Python, in fact, you are allowed to use either double quote like this or single quote. Both of them are possible. Actually, let me call it my name. There you go. What can we do with strings? Let's say I want to find out whether a particular letter M exists in my name. So I will just say M in my name is true. X in my name, false. I could also give a longer string. Som in my name, true. Sum in my name, false. Now, what else can you do with string? A good way to find out what you can do with string is to do this. Let's say you have created a string variable called my name. There are a lot of utility functions, or in Python we call them methods, that you can use on a string. And to use those functions, you would write this name and then put a dot and then write the name of the function. As you see here, as soon as you write dot, Colab has immediately prompted you with all the functions that are defined for strings. So you don't have to really remember. You can kind of use it as a menu and find out what you need to write. So as an example, let's use this one, capitalize. What does capitalize do? Okay, it didn't really, you got something that, not sure what it did. But the idea is that when you call a function, you need to provide parenthesis, because that is when that method or that function actually gets executed. Otherwise, it just tells you that there is a function. It doesn't actually run it. So let's try with this parenthesis. All right. So it capitalized it. Basically, what it did is it turned the first letter into a capital. In fact, if you hover your cursor right above this, you will see what we call doc strings. That is, it tells you, it gives you a definition of what this function actually does. So why don't we try some other Python functions just for fun? What else can we do? Dot ends with. What does that do? So it gave an error. What it's telling you is that ends with takes at least one argument. It means you basically asked, my name ends with, but you need to tell, like, ends with what, right? So ends with what is an argument. If you hover yourself here, okay, it doesn't tell you, but you need to basically say ends with P, true. So ends within is an example of a method which takes an argument. What else do we have in strings? My name dot, let's try upper. It converts the whole string into an uppercase. Similarly, as you might imagine, there is also a lower, converts it into lowercase. Uh, what else? Another useful one is split. So, well, it didn't really split. You actually have to tell split using what? By default, it splits using space. So let's split by name with M. That means wherever there is an M in my name, it's going to break it there. So say it created so tip. Actually, let's give a more interesting example. Mm, let's create a sentence. Yeah. I have an apple. And then we do sentence dot split. I'm not going to specify anything. So it's all, like, by default, it's going to split by space. So it split the sentence into, words. So these are some very, very simple things that you can do with string. And of course, as you're trying it out, um, just do this dot and play with anything that you want to. So far, what have we learned? We have learned the variable integer, floating point, and we have also learned strings. In fact, we have seen one more. if you notice here, the result of this particular expression could have only taken two values, true or false. So in this particular case, actually the result is a variable of type Boolean. So in fact, if we assign it to a result and then we check the type of this result, we'll tell that it's bool. So far, in the last 10 minutes, we have learned four variable types: integer, floating point, strings, and booleans. So before I end this, so note that with booleans you can also do logic, like logical things like and or. You can ask things like um, my name dot starts with S and my name ends with P. You may have noticed the autocomplete here, which is very handy. So what we have done here is we are doing an AND operation using one res expression and another expression. Right. So let's now, before we move on to any break, let's move on to the next topic. But yeah, please feel free to ask any questions that you have so far. And all of this, the stuff that I'm typing, you will have access to that in the link that we will provide you at the end. So the next variable type is a list. A list looks something like, let's call it a time points equals 0.5, 1, 2, 3, right? Type of time points is list. With list, you can do iterative things. So for example, what you can say is that for point in time points, print point, and it's going to print all this point, or print point times 10. So this is called iteration. Whenever you have a list, you can iterate over the list. That is, you can go over every element of that list and repeat the same operation. Let's try something else. Points. What what if I time point time 4? What would you expect? I don't know if that is what you expected. If you expected every number to be multiplied by 4, it clearly did not do that. So in Python, when you multiply a list by an integer, what it really does is it makes copies of this list and adds it again and again. So here you see this list just got repeated that many times, right? And what if I try to do time points plus 4? It complained. It doesn't like it. It doesn't like adding a single number to a list. What if I say time points plus this? One list plus another list. So this is what it does. It just uh, add the second list to the first list. In fact, if this was like that, here's what you get. So I see one question, will it also pop up in a table format? Well, I don't know exactly what you meant, but it's not going to do any fancy formatting. Some of the fancy formattings are done by data frames, which we will see in the um, week 2 lecture. But at least here, it simply shows the result just like that. So clearly now you might be thinking that, oh, this is not good. Like if if how do I do things like if I've got a list of numbers and how do I multiply everything by 4, add 4 to everything? Those are operations typically as a scientist you would want to do and something that you actually do often in R. So the answer is that for that kind of an operations, you would use something that is popularly used is a library called NumPy. So now let's move on to that. A library or a package. So what exactly is a package? One of the main uh, differences, or one way Python is quite different from R, is that in R, a lot of the standard um, functions, standard math things comes with the base package itself. But what Python does is that the basic language has a very minimal feature set. Everything that you want for particular applications, whether it's for science or whether it's for machine learning or whether it's for um, word processing, they are available as separate packages. This allows you to specialize. You just take what you need. So one very popular package is called NumPy. And whenever you want to use a package that does not come with a basic Python, the first thing you have to do is you have to import it. So you import NumPy. NumPy, as you would guess, it's short for numerical pi. It was developed by a set of developers who are independent from the core Python developers, but it became very popular. So it is almost everybody who uses uh, Python for science or math end up using NumPy. So now we have imported NumPy. So what we can do now is we can say, instead of defining time points like this, I can actually say time points equals, just remove it. I can say time points equals numpy dot array and then pass this list like that. So this would created, instead of a list, it would create a numpy array. Time points. This is how it's printed. If I check what type is it, it is numpy.endarray. And because NumPy is so popular, what many people find is that, well, they get lazy. That do I have to type NumPy again and again because I want to use NumPy array, I want to use NumPy this, NumPy that. So they would do something like this: import NumPy as NP. So when you do that, it means you have basically created an alias for NumPy. So now you don't have to do NumPy, you can just call NP. Well, it's just a convention, but it has kind of become a very, very popular convention to import NumPy as NP. So it basically would do the same thing. The fun thing is now that you have a NumPy array, now if you do math with it, you will see that it does some of the things like you expected before. If you do time points times 4, it multiplies each number by 4. If you do time points plus 4, you get this. What else is some fun things we can do? Okay, let's try to the power 4. And yeah, it's still doing the same thing. 3 to the power 4 is 81. Note that it's printing it in the scientific notation. Times 10. In fact, you can also do things like e to the power these. So because NumPy is so popular, NumPy ends up having almost all of the popular scientific functions are available in NumPy. If you just do np dot, you will see the whole catalog. And so one of them is, for example, mp.exp, which basically means e to the power your input. So here you got e to the power 0.5, e to the power 1, e to the power 2, e to the power 3, and so on. So you would have realized that while basic Python lists is not like how vectors and matrices are in R, but NumPy actually is a more one-to-one equivalent of how you do math using vectors and arrays in R. So in fact, it doesn't even have to be 1D array. I could also say, in fact, this was a one-dimensional array. I could have also made it a two-dimensional array. Row 1, comma, 4, 5, 6, you know. Okay, what did I do wrong here? Oh, another thing you would be want to develop the knack of is how to read errors, because as you're learning, you'll be doing mistakes all the time. So, and yeah, it is very good at telling you exactly what went wrong. So it's telling me closing parenthesis does not meet opening parenthesis. It means, yeah, I have too many brackets in the front, but I'm not closing them. And it actually tell you exactly which one was not closed properly. So it's not this one, but the next one. Right. All right. So now everything is good. Okay. What did I do now? Time points is NP array. Let me just print it. Oh, well, let's just read the error. The requested array as an inhomogeneous shape after one dimension. What it's basically telling me is that, I defined two rows, but they are not matching. See, the first row had 4 elements and the second one had 3 elements, which is not good. So let me just match that. Okay, now everything is good. Time points, time 10. Here you go. So now you see here that whatever math we could do with 1D array, we could also do the same with 2D array, and you could also make it 3D array and so on. All right. I have now covered NumPy. Next. Well, we could do simple addition, multiplication. We also tried exponential, but NumPy actually also does have a whole assortment of things, as you can see here: absolute value, cosine, addition. You can do, for example, you can do log time points. You can also do SQ square root. You can do sine, sine, cosine, pretty much, any mathematical function that people popularly use, chances are that, NumPy has it. So I think I can, oh, well, before I stop with basics of NumPy, I will just do two more examples. Let's go back to yeah, let's just stick with this. What happens if I do np.max? What it did is it took the two-dimensional array and it calculated the maximum of across the everything. It found a single element which is the maximum out of the entire matrix, as opposed to np dot maximum. What does that do? Points. Uh, it errored. It said, well, this maximum function only works with more than one array. So let's say maximum of time points and 2. What it did is it did an element-wise maximum. for every element, it gave you the maximum of whatever is that element or 2. So like, for example, here, maximum of 0.5 and 2 is 2. For the fourth one, maximum of 3 and 2 is actually 3, and so on. So I just wanted to point out here is that you just need to be aware of which function does what. Dot max does a maximum across all the elements, whereas maximum does a one-to-one maximum by element maximum, that is. Okay, so I think I'm going to stop here because for our first question break. So far, I have introduced all the common data types: integer, float, string, boolean, and I have shown how you can use NumPy for matrix and vector operations. So before I move on to the next topic, anybody has any questions? So one question came in, how to make data frame. I was actually planning to introduce data frame in week 2.
So if any of you have questions, please raise your hand and I'll be able to unmute you to ask the question.
So
I
another
see
question is,
Manish has a question. Yeah, go ahead, Son.
will we use NumPy? So today we are going to use NumPy, SciPy, and Matplotlib. So 3 packages we will learn. Uh, in week 2, we will use data frames, and we will use some more packages with ML libraries. NumPy is extremely popular for most common mathematical operation. Yeah, it's kind of the standard. Okay. So why don't I then move on to the next topic? Uh, let me just delete some of these things. So after this, I was actually going to introduce you to another concept called functions. So before we do that, how about we do, so far you have not seen anything related to PK, right? So how about we, you know, have our first flavor of PK? Let's say we want to define a one compartment model. And what does the one compartment model look like? One compartment model looks like something like, uh, say this. And if you're wondering what I'm typing over here with this dollar and everything, I'm also showing you that in Google Colab, you can also have um, formula using LaTeX. So this is not code. This is the part where you write your notes. As you can see here, I can also use mathematical formula like this. So how about we define a formula like this using code? Well, if we were to use NumPy, that would be like, first let's define T. Before that, we'll do import NumPy, and then we'll do time points. In fact, we don't have to define T as a single number. Let's just define T as a vector. Do it like that. So that's T. And now, how do you do the formula like above? Well, it's simple. You just say 10 times np dot exp minus 0.2 times time points. So that basically gives you the constant. this is concentration, from a one compartment model. So now you got the expression for of concentration as a function of T. Now here I of course hard coded the things. I just wrote 10 and 0.2. But let's see if you find yourself in a situation where you need to create the one compartment model again and again, possibly for different values of these coefficients. You could define a function. What does a function look like? A function looks like the following. You first say, I am going to define a function, def. So that's a Python keyword. Then you are going to give it a name. You can really give any name you choose, and just based on what I preached before, I'm going to pick a long name that explains itself. So I will call it one compartment model. I'll give it an even longer name, IV bolus. Okay. So this is the name of my function. What does my function do? It defines a one compartment model, but for that, it needs to know two things. It needs the input. Let's put it at first. Let's call it T. That's what it will take as the time input. And then it also needs two parameters, say A and alpha. And then the result, it returns that. So what I've done here is I've just defined the same expression, but using parameters that are not hard-coded. In other words, I have just defined it as T, A, like that. I've defined a compartment model that looks like this. What can I do with it? I can call the function. I just need to provide the T, A, and alpha. So if I want to get the same result, I will just say call one compartment model. The first parameter T, just pass it the time points. The next one is A. Let's call A as, let's keep it the same, 10. And alpha is 0.2. Okay. I think I mistyped, right? Oh, I didn't mistype. I actually did not execute this. So even though I typed it, I did not run it, so it's not defined. So now I'm going to run it, and now I'm going to run this. Okay. So this is how I have defined a function that defines a one compartment model. Now, all right, now what if I want to see the function in action? What can I do? Well, gee, we just executed it. How about plotting the numbers that we just got? Why don't we do this now? Just for fun, you have seen the Colab has been constantly prompting that, start coding or generate with AI. So let me just take up on that offer. So this way, and I'm basically doing this to show you that while it is good to understand the basic concepts, you don't, these days, particularly with AI, you don't really have to memorize every single function signature because AI can help you with it. So instead of memorizing what plot commands I need to do, let me just ask plot one compartment model result versus time points using Matplotlib. Actually, I don't even have to say Matplotlib. Let's just see what it does. Okay. All right. So I'm just going to say accept. Now, one thing I will tell you is that, well, using AI, you can write a lot of code, but whatever code you write, please make sure that you understand what came out of it. That is, make sure that you go through line by line and know what code did AI produce, because AI is very good at, it produced this 10-line function in like a few seconds and you didn't have to remember the syntax. But then it doesn't work 100% of the time. Sometimes it produces things that you did not want. So you just want to make sure you know what this is doing. So I'm going to now go over every line to understand what each line of this code is doing, right? So the first one is an import. Remember, I told you that every advanced function has to be imported. So Matplotlib is a package in order to produce plots, and it's not the only one. Python has other packages like Seaborn, Bouquet, and each of them have its advantages. Matplotlib is quite popular. And in fact, there is another package, I'm forgetting the name, which does exactly what ggplot does. So those of you who like ggplot in R will also be able to do exactly those things using another Python package. But this one is Matplotlib. Now I have imported it as PLD. Then what I did here is it executed the one compartment model using time points as input, and it got the results here. So so if you recall, time points is a vector of time points. Model results is the output. So basically, these are the X, these are the Y. Now all I need to do is plot this X and this Y. So first, it defines the plot. This defines a plot area, 8 inches by 6 inches. Then it calls the plot command. And in fact, if you're wondering what the inputs are, you can again bring your, let me just execute first. Bring your cursor right above plot and it will tell you what the inputs are. So like, for example, you can read. This is how you can read the documentation of plot without actually going to a documentation website, simply by using your cursor. So here you see it tells that the first argument is X and the next is Y. It gives you a lot of examples also here. So the first argument was X, next was Y. This one tells you that use O for marker, use this for line, and you can play around with by using different line styles. This one gives you the X level, this one gives you the Y level, this one gives you the title. They are all very obvious ones. If you want to see what happens if I don't do this, you can use this. That's something I haven't mentioned before. Anytime you have a line in the coding area that starts with a hash, that's considered as a comment. So it's not going to execute it. It's going to treat it just as comment, ignore. You can put your notes here. If I execute without this, there is no title. With this, there is a title. Yeah. There is also something called legend. Oh, well, actually, I did not name the lines, so I'm not seeing any legend, but we will see that in a, I have to actually give it a label. What was it? Okay. Now that I've given this plot line at label, it shows up in the legend. And here again, I want to just go over the basics. I don't want to go too deep into the syntax because, as you saw, you can use AI to pretty much generate the code you want. You just need to have a high-level understanding of it. There is, I think, one more thing I wanted to tell you. Okay, let's go back here before we take a break, right? Where did I define the function? Right. Now, in order to define a function, usually it's enough to just do this. Diff, function name, arguments, that's it. However, as when you write functions for yourself and you wanted to come back to it a week later and try to understand what did I do here, you want to add more comments. There are several ways to write comment. One is, of course, you can just do hash and you can just type in whatever you want. However, Python has a concept called doc strings. Every time you define a function, right after the function definition statement, there is a section where you can give a detailed description of what this function does. And the syntax for that is that you start with 3 quotes. Then you tell what this function does. You would say one compartment model for PK. So that's your function description. Then you will write another section called parameters. And here you'd explain what is T. T is time. A is your coefficient. And alpha is your rate constant. And when you're done, close it with these 3 things. So this is a very standard practice used by most people who write code that they want late, so that they can later on come back and know what they actually did. If you want to find out more about what is the syntax, you just need to Google. It's called NumPy doc strings. If you Google NumPy doc strings, it will take you to the style guide, and that tells you what is basically the best practice, how you should write documentation for your functions like that. Okay, so that's part 2 done. Before we move on to the last part for today, actually I'm running a little bit short of time. I may have to go a little faster. So any questions so
So,
far?
thank you, Somdeep. This is again great examples and great work. So, just as Somdeep mentioned, time check, we have about um, 10 more minutes of this workshop uh, that Somdeep would be covering one more topic in. And in the meantime, I will also share the Google Colab write up as well as all the material and homework assignments. So, Somdeep, just wanted to mention to you that we will need to give at least 5 minutes at the end for us to discuss the homework assignment and what is expected.
Sure. Yep, we'll do that. Yeah.
So if anybody has any questions, please put it in the chat. And in the interest of time, we will move on to the next topic.
Okay. So one question is how to import data from Excel, etc. Well, this is also something I will be covering in more detail in week 2, but it's as simple as a function called, for example, when we learn data frames, it would be something called uh, pandas.read CSV, and it would be able to read your CSV file from your local machine or from even from a website. But yeah, this is something we will cover more in week 2. Right. So now let me jump onto the last topic of the day, and which is also leading to the homework. And this is about fitting. So what we did so far is that we did create a one compartment model, but we just hard coded the parameters. But very often, or you usually have some data, and then you want to fit your parameter to that model. So how do you do that? So let's start with the basics. First, you all, of course, need to import your packages. And I'm just going to define some data points. All right. So what I've done here is I have defined two lists, the list of time points and the list of observed concentrations. And actually relates to something that Kirmani just asked, how do you read data from Excel? So here I have coded it right here, but yeah, in practice, you would often be reading it from a file. We'll cover that in week, right? Now, what we got here so far, we got a bunch of time points, we got a bunch of concentration. What do we do? Let's first try, let's just try plotting it, why don't we actually ask this guy? Plot concentrations versus time points. All right, accept. So let's just go over it. Did the right thing. I did a figure, plot, X level, title, grid, fine. Let's just do that. Okay. So it plotted the concentration across time. One way of fitting the data is, of course, linear regression. We're not going to do that today. And you can, of course, clearly see that linear regression is not going to fit this data very well. What else can we do? Well, we have just created a one compartment model before. So why don't we try to use the one compartment model to fit this data? Okay, so the one compartment model that we had created looked like this. It takes a T and A and alpha and returns a number like this. But we don't know A and alpha. So what do we do? So here comes the next package. It's called SciPy.import curvefit. It's called curvefit, and the package is called SciPy, SCI for science, right? So SciPy actually has a lot of curve fitting, optimization, and that kind of uh, statistical models and things like that. With curve fit, we can actually find the value of A and alpha that will best fit this data. And for that, what do we need? What do we need? So let's just do curve fit. Actually, why don't I just type it here, the example. So curve fit function, I'm just going to execute it first. But it is not, it is because I did not do this. All right. So the curve fit function takes a bunch of input parameters. If I bring my cursor here, I'm going to see what, and it defines all the parameters it takes. The first one is the model. What is the model you want to fit? And there is some expectations how this model, what this model should be like. This model should be a function like we have defined here. The first parameter of that function should be the x value. And after that should come all the parameters. So because this is a one compartment model which takes two parameters, so this is how the function is. First the x value, which is t, and then the parameters a and alpha. Okay. Then the next thing in the curve fit should be the time points, the original time points, the x data. The third thing should be the observed y values, observed concentrations. Then the rest are actually optional, but it's good to get a good fit. You can define the initial parameters, that is the initial values, initial guess of the parameters. And recall that the parameters, there were two parameters, A and alpha. Therefore, these initial parameters are also two. Then a sigma, it's also optional. Um, Basically, the variance, it helps the fitting function not to know whether it should take small steps or large steps. And this just tells that sigma is absolute. And lastly, it's also an optional parameter, the bounds. Uh, what this says is that the first parameter should be between 0.1 and infinity. The second parameter should be between 0.1 and infinity. The lower bounds and the upper bounds. And if I execute, it gets me the output is basically the optimized parameters. So let's just see what I got. P of 1. uh, P of 1. All right, so it gave me value of A is 9.55 and value of alpha is 0.192. So I can actually now calculate the fitted line. Fitted line equals, I run the one compartment model and simply pass the values of uh, values, the optimized values that I just got. Okay. Here is the fitted line. And you want to see how good the fitted line is. Let's just do that. Let's go back to this plotting code. Do the same thing, except I add one more line where instead of observed concentration, I'm going to pass the fitted line. So observed concentration is a list that we observed, and fitted line is also a list, except that it came from this function. And this one, I'm not going to do marker. I'm probably going to do, yeah, I'm just going to do anything. So it's going to do a line instead of marker points like O. And I'm going to change the label. Observed concentration, no, fitted line. All right, so there you go. Now, well, it fit better than a linear regression, but it still clearly did not fit very well. But we have learned the concepts, how we can take a model, it can be any model, and we can still call the same curve fit functions to produce the result. So what I'm going to do here is I'm going to jump back to my overview and tell you what the homework is. The homework is basically what we just did is we use the one compartmental model. And when we share the resources, you will also have the code that we use to produce that. What you need to do is you need to change that in order to use a two compartment model. So instead of just AXP, you need to use the formula for a two compartmental model to improve the fit, right? Same thing as we just did, except you will use a two compartment model with this formula and which has 4 parameters. I will give you one hint that you need to be aware of. Actually, let me just make it bigger. Because the one compartmental model had 2 parameters, it came right here, after T. And because it had 2 parameters, when you did the curve fit, your initial parameters, your bounds were also in 2s. And the result that came out of curve fit, that also had 2 parameters. When you use the 2 compartmental models, just remember that instead of 2, 2, 2, everything, all of this should be 4, 4, 4. Okay? So that's So that's all I just wanted to mention. And yeah, so your homework is just redo that exercise using the two compartment model. And in fact, I'm also going to just share the link of this spreadsheet into the chat so you can all bookmark it. Okay. You will find this presentation. You will also find here the links to all those spreadsheet, which has all the code that you just saw. Well, I'm going to stop here. Over to Aruna.
Thank you again, Somdeep. Uh, excellent first day. So, to all the participants, a few reminders. One is that we will send you a recording of this workshop will be posted on YouTube, and we will send you the link as well that you can use to review. We will also share the link to all the slide deck, the homework assignment, all of that will also come to you via email. So you will have access to all of that as well. So before you start working on the workshop homework assignment, I would strongly recommend that you re-execute all of the code that you saw Dr. Datta share today. That's how you will get your fundamentals strong. Following that, you can move on to doing the homework assignment. What we will also provide you is a name of a leader that you can reach out to if you have questions to, and it would totally depend on the team leader on how they want to have, whether they want to have a short meeting where all of you can attend to go over the assignment together, or if you want to connect with them one-on-one. Something else I also wanted to take your permission for is that we would create a WhatsApp group using the phone numbers that you have provided to us while you filled out the form. For any reason, if you want to update the phone number, please let us know. But at the same time, what we will do is to create that group so you will have access to other team members as well. So it is 11:28 a.m. We literally have 2 minutes left for us to conclude today's call. Just wanted to give you a couple minutes to ask any questions or if you need any further clarifications. Let me check on the chat if anything came up. All right. I see a lot of thank yous in the chat. Again, thank you so much for giving us the opportunity to share a bit of the knowledge that we have. And as we request, please do take on, completing the homework assignment. That's the way that you would actually learn this material, and also take on sharing this information or teaching someone else what you have learned in this workshop. So with that, I am declaring the workshop complete for today.
So there was
Thank
one
you all for
question.
joining us.
There
Sure.
was one
Go ahead,
question. How
Sonia.
can we? How there was a question. How can we get data for the assignment? So from the link provided, you will have a link to 5 or 6 worksheets, and one of them is for the one compartmental model that we just saw, and that has the data. So that has the data and the one compartment model too. All you need to do is copy it and modify it to 2 compartment.
And there was another question that says, will we be receiving a certificate of completion? Yes, all the participants who complete their homework assignments by the allotted time will actually get a certificate of completion. Yes, you will get the recording of today's workshop. And you will also get the access to the slide deck that was presented by Somdeep. Thank you, everyone. Again, great day one of the workshop. Looking forward to seeing you on the day two of this workshop. In the meantime, we'll be in touch with you via email. Have a great rest of the day, evening. Looking forward to seeing you next week. Bye bye.